Okay, we're going to go over the 17.2 section. So 17.2 is law of sines. And the first part is just showing you how we get the formula for the law of sines. You will have to memorize the formula for the test, but you don't have to know how we get the formula. I'm just going to show it to you. So if you don't want to know this part, you'll have to fast forward. So if you notice from when we did the area of a triangle using sine, we had basically three formulas. It was 1/2, we had BC sine of A. We had 1/2 AC sine of B. And the last one was 1/2 AB sine of C. Now if I take this formula that I have and I divide it all by 1/2 ABC, we'll be able to cancel some things out. The 1/2 is going to cancel. Here the B and the C are going to cancel, but you're left with A here. 1/2 will cancel here. The A and the C will cancel. You're left with a B here. 1/2 will cancel. The A and the B will cancel, and you're left with C here. So if you take a look at this final setup, we have sine A, and that's angle A, over side A equals sine B, that's angle measure B, over side B, which equals sine angle C divided by side C. This is the law of sines formula. Okay. Now we're going to use this to solve for any triangle. And when I say solve for any triangle, you can solve for all the angles and all the sides as long as you know this bare minimum information. So this allows to solve for any triangle if you know this is the first case scenario, any two angles and a side. Shortcut for writing that is angle, angle, side, or angle, side, angle. So the side could be either not between or in between the two angles. You could have this case scenario where you have two sides and the angle not between. So that would be side, side, and the angle not between. Remember, we're not proving triangles congruent. We're just saying which of these triangles can you use the law of sines. So if you know two angles and a side, whether it's in between or not, or if you know two sides and the angle not in between, that's when you can use the law of sines to solve. So let's do a couple of examples here. Solve the triangle and round to the nearest tenth. And this is an S, not a 5. So we have 35 degrees, 38 degrees, side length here is 15. Now notice these don't have the letters A, B, and C like we have up here. But really it's this angle is across from that side length, this angle is across from this side length, and this angle is across from this side length. So if you think about it, this is angle S across from S, we have angle T across from T, and we have angle R across from 15. So what we need to do is we need to solve for the triangle. When it says solve for the triangle, that finds all the angles and all the sides. And if you take a look, let me move this up a little bit. If you take a look at what information that's given, I have two angles. Knowing two angles means I can find that third side. third angle. Because what do all three angles of a triangle add up together to be? They add up together to be 180. So I'm going to go ahead and find first what is the measurement of angle T. And that's basically taking this and taking 180 and subtracting what these two add up together to be. So these two add up together to be 73, and so this gets you a total of 107 degrees for angle T. So that's one. And now we're going to go ahead and use the law of sines to solve for the side length. Now remember, what was given to me is two angles and the side. The angles that I have, the side is not between them. So it's angle, angle, side. So we can use this property. All right, let's go ahead and solve for a side length. Now what I have to look at is look for a pair of information that I know, an angle and a side across from each other. I know angle R is 35 and I know the side length along with that. The other ones I don't know, so I have to use this to find the other two sides. So the setup is sine of the angle, so angle is 35 degrees, divided by 15. And now I can choose. Do you want to solve for angle S? I mean, not angle S, side S or T? I'm going to use S first, so I'm going to use 38 degrees. Sine of 38 degrees over S, and that's what we're solving for. All right, I'm going to go ahead and cross multiply. So when I cross multiply here, I get S times sine of 35 degrees equals 15 times sine of 38 degrees. And then what I'm going to go ahead and do is divide both sides by the sine of 35 degrees. So this cancels, and then basically what you're doing is you're going to plug this into the calculator. Make sure you are in degree mode. So 15 sine 38 divided by sine of 35. Excuse me. I'm going to go ahead and plug that in right here. I am already in degree mode. As you can tell, it says degree right here on the top. And then, let's see, it's a little blurry there. Let's see if that fixes it. All right, so we have 15 sine of 38 degrees. Make sure you end the parentheses before you divide sine of 35. And that gets you approximately 16.1 when it's to the nearest half. So 16.1 is side S. And now we all have to find is side T. Remember that this is not, oops, move that. Remember that this is not a right triangle, so you cannot use Pythagorean theorem. We're going to have to use the law of sines again. Sine of 35 degrees divided by 15 equals, and then we're going to use sine of angle T, which we found up here was 107, over, and then T. Again, we're going to cross multiply. So we have sine 35 times T. So T times sine of 35 degrees equals 15 times sine of 107. And then I'm going to go ahead and divide both sides by sine of 35 degrees. And I shouldn't forget my degree symbol, right? Okay, and then T is going to be approximately, let's plug that in. So we have 15 sine of 107, end the parenthesis before you divide by sine of 35, and that gets you approximately 25.0. Okay, so that's one example. Let's go ahead and do one more example of this. So we have triangle ABC. This is 33 degrees up here. And I know that this side length here is 15. This side is 12, and I want to solve for this side as well, A. All right, let me scoot this down a little bit for myself. Okay, so let's go ahead and look at the information that I have. I don't have two angles, so I can't find the third, but I do have a pair of information, the B's. Angle B with side B. So I'm going to use that to solve for all the other sides. So first of all, I do know 15, so I don't know any of A. So I am going to solve for angle C first. All right, so let's set up the B's. That's sine of angle B, which is 33 degrees, divided by 12 equals, I don't know angle C, so I'm going to say sine C over 15. Okay, that's the set, and this is a set. All right, I'm going to go ahead and start by cross multiplying. So I have 12 times sine C equals sine 33 times 15. I usually write the number in front of sine. All right, I need to get my sine by itself. I'm sorry, sine C by itself, so I'm going to divide both sides by 12. And then the last step is to get rid of sine. And in order to get rid of a sine to solve for an angle, you have to use the inverse. So inverse of sine. And remember, you can do the inverse of this whole thing here. So we're going to have to put in the second button and then put all this inside the parentheses. Okay. All right, let's go ahead and see what that looks like. So let's go ahead and plug it into the calculator. So we have second sine, and if you like the fraction, remember how you could put in a fraction by hitting math button, arrow to fraction, and select number 1. This is an option. Otherwise, you could just put it all in as one shot. I just wanted to show you another way. Okay, and angle C is approximately 42.9, and don't forget your degree symbol. All right, so that's angle C. And since I now have angle C, I can go ahead and find angle A so that I can use the A's. So how do you find angle A? Well, if I know this is 42.9, I can subtract that from 180 to get the missing angle measure. So to find the measurement of angle A, basically you're taking 180 and subtracting what these two add up together to be. So 42.9 plus 33 is 75.9. And if you subtract that from 180, you get 104.1 degrees. All right, so I know angle A. And now I can go ahead and use the same ratio here and pair it with the A's. So sine of 33 degrees over 12 equals sine of angle A, which I know is 104.1. degrees over A, which is the last part I'm solving for. All right, let's cross multiply. So sine 33 times A, we have A sine of 33 degrees equals 12 times sine of 104.1, 12 sine of 104.1 degrees. Divide both sides by sine 33. All right, so these cancel, and then so you're just basically plugging this into the calculator. So I'm going to go ahead and plug that in. We have 12 sine of 104.1 divided by sine of 33. Make sure you end the parentheses. And you get a total of 21.4. And this is not an angle, this is a side length, lowercase letters. All right, I'm not going to do another example. I'll just do a little reminder that when you have similar triangles, all the angles, corresponding angles, I should say, are congruent. So if I had a triangle, and let's say it's A, B, and C here, and I know this is similar to the small triangle DEF, and I know this top angle is 32 degrees, and let's say I know this corner angle right here is 62 degrees. If I'm working on this triangle and I know these are similar, that F is going to correspond to angle C, so I'll know this is automatically 62 degrees, which will help me find the rest of it. I'll find that missing angle by subtracting from 180 and then finding the side lengths using this law of sines. Okay, so that is it for your law of sines lesson.